Hello friends, continuing with the topic of electronic devices. Today we come to another device called as transistor. Previously we have studied electronic device diode, and now we are to study about transistor. Now what is a transistor? The word transistor is made up of two words, transfer plus resistor. Trans has been taken from transfer and ester has been taken from resistor. On joining the two, it comes out to be a transistor. Voltage is amplified across a transfer resistor due to transfer of resistance from input to output. There are many types of transistors: bijunction transistor, unijunction transistor, field effect transistor. Now here we are to study about bijunction transistor. Introduction to bijunction transistor. It is a three-terminal semiconductor device in which two p-n junctions are connected back to back to form a uniform crystal lattice as shown in diagrams. The three terminals are known as emitter, base, and collector, and are denoted by E, B, and C. Second, terminals. Base terminal. Which is base terminal? N-type material sandwiched between two p-type materials, or p-type material sandwiched between two n-type materials is known as base and is denoted by small b. Here you can see this n-type material sandwiched between two p-type materials and is known as base. Here p-type material sandwiched between two n-type materials is known as base. And now emitter terminal. The portion left of base is called as emitter. The portion left of base is called as emitter and is denoted by small e. Third, collector terminal. The portion right of base is called as collector. The portion right of base is called as collector and is denoted by C. Okay. This is how we have the terminals of transistor. So it's a three-terminal device. So we have three terminals, one for emitter, one for base, one for collector. Third, doping levels. Now, doping level of emitter is more than that of collector. That is, resistance of base collector junction, RBC, is more than resistance of emitter base junction, or EB, and base is lightly doped. Fourth, area of contact. Area of contact of base collector junction is more than that of emitter base junction. Device voltage or current operated. So which kind of device transistor is? It is voltage operated device or current operated device. Now transistor is a current operated device which has many advantages over voltage operated device. Some of the advantages are listed below. Transistor is small in size, economical, durable, long shelf life, high efficiency over vacuum tubes, which are voltage operated devices. So many advantages. I repeat, small in size, economical, durable, long shelf life and high efficiency over vacuum tubes, which are voltage operated devices. These are preliminary informations about transistor. Type of transistors. Transistors are of two types. First, PNP type and second, NPN type. Circuit symbols are as shown. This is PNP type transistor and this is NPN type transistor. You see in the diagram, arrow is placed in the emitter leg. In PNP type transistor, arrow is directed inward towards the base, and in NPN type transistor, arrow is directed outward away from the base. So this is PNP transistor, this is NPN transistor. So wherever you see such type of diagrams, you immediately decide which type of transistor is this. Okay. Now arrow in emitter shows direction of flow of holes. So wherever you see the arrow will tell you that this is the direction of flow of hole current. Okay. Now second, biasing a transistor. In order to put a transistor to use as an amplifier, oscillator, modulator, switch, or for any other application, it needs to become ready for action, and for that purpose a transistor is to be appropriately biased. Like a vehicle to run on the road needs petrol and mobile oil for respective purposes. In the same way, transistor needs bias. Bias is nothing but application of electric field. Okay. Now biasing. What is biasing? It is the process by virtue of which a PN junction is applied with an electric field in order to make current flow through it. A transistor has two junctions. Therefore, each needs to be biased properly. Thus, emitter base junction in a transistor is always forward biased and base collector junction is always reverse biased. Now let us apply bias to the transistors. Look at this diagram and this diagram. This is PNP transistor which has been biased. Now PN junction, this emitter base junction is forward biased and base collector junction is reverse biased. If we use symbol, then emitter base junction is forward biased, base collector junction is reverse biased. Okay. So this way we can give bias to the transistor for making it ready for action. Now this is NPN transistor. Okay. Now in NPN transistor, emitter base junction is forward biased and base collector junction is reverse biased. Now in the symbolic form, you see emitter base junction is forward biased and base collector junction is reverse biased. So this is how we apply bias to the transistor. In this situation, when emitter base junction has been given appropriate bias, base collector junction has been given appropriate bias, it becomes ready for action. Now third, operation of transistor. Since we have two types of transistors, NPN transistor and PNP transistor, so first we take up operation of NPN transistor. Now let us see what happens at emitter base junction when emitter base junction is forward biased. Emitter base junction being forward biased, majority electrons from emitter enter into base region. and holes from base region enter into emitter region, constituting base current IB, which is of the order of microamperes. Now let us see what happens at base collector junction. Base being lightly doped, 10% of the electrons entering base region are neutralized and 90% are attracted by positive of reverse bias battery. Enter collector region constituting collector current IC and is of the order of milliampere. Now collector current is of the order of milliamperes. Now IE is composed of base current IB and collector current IC. This IC is slightly less than IE, sometimes can be taken equal to IE. Now equivalent circuit of transistor. Here is the equivalent circuit of transistor. So this is emitter region, resistance of emitter region is RE. This is base region, resistance of base region is RB, and this is collector region, which is whose collector resistance is RC. So this is how we draw equivalent circuit of transistor, because base is common between input and output. So this is input, this side is output. Now fourth, current equation. According to Kirchhoff's current law applied at point P, we have minus IE plus IB plus IC equal to 0. Therefore, IE is equal to IB plus IC. Since IB is of the order of microamperes, therefore IC sometimes can be taken as equal to IE, because those both are in milliamperes. We can write IE approximately equal to IC. Now fifth, question rises, why base is lightly doped? If emitter and base are equally doped, then all the electrons entering base region will get neutralized and no surplus electrons are available for entering into collector region to constitute collector current. Therefore, system would not work. Hence, base is always kept lightly doped. Now 3. Operation of PNP transistor. So this is the circuit diagram of our operation of PNP transistor. This is forward bias, this is reverse bias. Emitter base junction is forward bias and base collector junction is reverse bias. Now first we look at emitter base junction. Emitter base junction being forward biased, majority holes from emitter enter into base region and electrons from base region enter into emitter region, constituting base current IB, which is of the order of microamperes. Now let us look at base collector junction. Base being lightly doped, 10% of the holes entering base region are neutralized and 90% are attracted by negative of reverse bias battery. Enter into collector region, constituting collector current IC, and IC is of the order of milliampere. IE is composed of IB and IC. This IC is slightly less than IE, sometimes can be taken equal to IE. We can explain operation of PNP transistor in the same way as we have explained that of NPN transistor. Now equivalent circuit. So this is the equivalent circuit of PNP transistor. This is emitter region, resistance is RE. This is base region, resistance is RB. This is collector region, resistance is RC. Now fourth, current equation. Now according to Kirchhoff's current law applied at point P, we have IE minus IB minus IC equal to 0, or IE is equal to IB plus IC. Now since IB is of the order of microampere, therefore IC sometimes can be taken as equal to IE, that is IE is approximately equal to IC. Now here you have to look at the direction of current flow, hole current flow and electron current flow. So you have to mark the direction of conventional current, and conventional current here is the hole current. Now fifth, why base is lightly doped. If emitter and base are equally doped, then all the holes entering base region will get neutralized and no surplus holes are available for entering into collector region to constitute collector current. Therefore, system would not work. Hence, base is always kept lightly doped. Now, let us talk of amplifying action of a transistor using NPN transistor. You have to explain yourself the amplifying action of a transistor using PNP transistor. Okay, here we take up NPN transistor. So first point, we have to understand what is an amplifier. Amplifier, you look at this diagram, this is amplifier, this is input side, this is output side. Now input side we give a signal, AC signal, and output side we can get AC signal which is amplified either this way or this way, depending upon the configuration of the transistor. Okay, so what is an amplifier? Amplifier is a device that raises the amplitude of input signal delivered at output with same phase or out of phase. So this is the signal with same phase and this is the signal with out of phase. Okay, so but the amplitude is more than the input in both the cases. So this block is an amplifier. B, the circuit using NPN transistor for explanation of amplifying action. Here is the circuit diagram for explanation of amplifying action of the transistor. Now see, under biasing conditions, emitter base resistance or EB is less than base collector resistance or BC because emitter base junction is forward biased, where emitter base junction resistance reduce, and base collector junction is reverse biased, where base collector junction resistance increase. Therefore, REB is less than RBC. Now D, equivalent circuit. Equivalent circuit is as shown. This is input side, this is output side. Now power dissipation in input circuit is IE square into REB. Now what is the formula for power? Power is I square R. So here I is IE in the input side and resistance is REB, junction resistance REB. Now in output circuit, power dissipation is equal to IC square RBC, because in the output circuit current is collector current IC and resistance is base collector junction resistance. So therefore, power dissipation will be IC square into RBC. Now since IC is approximately equal to IE and RBC is greater than REB, therefore IC square RBC would be greater than IE square REB. Hence, power dissipation in output circuit is more than that of input circuit, which causes amplification. I repeat, since IC is approximately equal to IE and RBC is more than REB, therefore IC square RBC would be greater than IE square REB. Hence, power dissipation in output circuit is more than that of input circuit, which causes amplification. Okay. Now assignment 14. Question number 49. Draw a circuit symbol of NPN and PNP transistors. Question number 50. Explain the operation of a PNP transistor and show that IE is equal to IB plus IC. Question number 51. Describe amplifying action of a transistor using PNP transistor. Thank you so much. Next time we'll take up the next part of it. Till then, goodbye and good luck to you.